All right, so let's review what projectile launched horizontally entails. As you remember, projectile motion is motion in two directions, vertically and horizontally. And we distinguish between two parts of it, between the horizontal part and the vertical part. And we do that not only because of the direction of motion, but also because of the nature. Projectile is linked with free fall, meaning that we disregard any air resistance whatsoever. We pretend there's no air, and we pretend that everything is falling down with the same acceleration that is due to gravity. And if we're talking about the Earth, then we have negative 9.8 meters per second squared, or negative 9.81 meters per second squared. It's negative because it's downwards. Meanwhile, again, because there's no air and no air resistance, we can say that horizontally, our projectile does not accelerate at all. So if you look at the diagram here, we are talking about projectile launched horizontally. So meaning at the beginning, it only has horizontal velocity, and velocity initial y is 0. So something can be rolled off the table, kicked off the cliff, or maybe it is a motorcycle jumping off, not going upwards, but just jumping off horizontally. Somebody's stepping off a diving board, something like that. So there's no vertical velocity, upward, sideways, anyway, only horizontal, just forward. So that would qualify for a projectile launched horizontally. The direction of motion is going to be kind of downward, sort of parabolic, horizontal and vertical parts. So it's falling down vertically and keeps moving horizontally. Now, again, like I started saying, since there's no acceleration, then our Vx is the same. Now, by the time the object hits the ground, it will have fallen through the vertical displacement. By the time it hits the ground, it has acquired a certain amount of velocity in the downward direction. And then the total velocity, which you see here, this one marked as Vf, that's the total velocity. And it will have a certain angle below the horizontal. Now, finding the final velocity and the angle below the horizontal will be only for the honors students. There are 3 types of problems that you will see on your quiz, and that is depending on what kind of initial data you will be given. So let's see what we have. We can be given displacement vertical, displacement horizontal, and initial velocity. And that initial velocity will be horizontal. Depending upon which of the 3 are given, you will be given 2 out of 3, and you will be asked to find the third. Let's say we have a problem in which something was pushed off a 2.5 meter platform with initial velocity of 15 meters per second. So your incoming data, we know Vx is 15 meters per second, and we know that our vertical displacement is 2.5 meters. Now, technically, if it's downwards and you would like to use g as negative 9.8, you can say that your delta y is also negative 2.5 meters. The question in that case could be how far from the edge of the cliff, or from the edge of the table, from the edge of the platform, will the projectile land. As you see, we distinguish between horizontal and vertical, and for horizontal, we only have one equation. Vx equals change in x over change in t. Now, we don't have the change in t, so if we cannot find t horizontally, we're going to go and look at our vertical. So what we do know is that our change in y is given, and we also know that our acceleration g is 9.81 meters per second squared. That's a given because we are solving for projectile motion, and therefore we assume that there is no air resistance, and then acceleration, which is g, is 9.81 meters per second squared. Looking at this formula right here, the steps you remember, you would do 2 change in y, multiplied everything by 2, then divided by g. That would give you t squared. So if you want to do t, you have to do the square root out of it. So then you're going to have, so the distance is 2.5, so double 2.5 is 5 over 9.81, 0.71 seconds. So if the time is 0.71 seconds, that is how long the projectile was in the air, going 15 meters per second horizontally. Then we can say that delta x is going to be Vx times change in t, and it is going to be 15 times 0.71, 11 meters. So again, The incoming data was something was rolled off a 2.5 meter platform, so that's the vertical displacement. With initial velocity of 15 meters per second, it was rolled off horizontally, so we know only horizontal velocity vertical is 0 because it's rolling off forward, not up or down. And we're looking for how far from the platform the projectile will land. Let's consider the second type of problem. We are given, again, something fell off a platform that is now 5 meters, landed 15 meters away from the base. So in this case, we're asked to figure out how fast it was rolling or kicked or thrown or flicked. Remember, you had a lab where you were flicking off markers from the desk. Could be something like that. Let's write it out. So we have our change in y to be 5 meters, and then change in x is 15 meters. Vx is our question. We cannot find time horizontally because we have two variables and only one equation. There's nothing we can do there. But if we know our vertical displacement, we can find for this particular, only for this one, if we know our vertical displacement, we can find our time using the formula right here. Again, the two steps, we will multiply by 2, so 2 change in y, divide by g, and we will square root to get the time. So it's going to be 10 over 9.8, so just a little bit over 1 second, and then Vx, using the formula right here, I know that the time is 1, then my Vx is going to be 15 by 1, 15 meters per second. This is a second type of problem where we were given, again, we were given two displacements and asked to figure out our Vx, the initial velocity with which the projectile was launched horizontally. Final type of problem is if we are not given the vertical, but we're given, let's say something is rolling off cliff at 2 meters per second, lands 40 meters away from the edge. How tall is the cliff? So we're given two things from the horizontal part. 2 meters per second is the horizontal velocity. 40 meters is the distance traveled horizontally. 2 and 40, both of them are horizontal. So we write it down in the horizontal part of our table. And then from there, change in t is going to be change in x over Vx. 40 over 2, 20 seconds. Then if the time is 20 seconds, then now we can do 1/2 9.81 times 20 squared. Again, this was for both horizontal components are given, the displacement and the velocity, and we are asked to figure out the height. So the last part of this video will be for honors students and for those who would like to earn some extra credit. Let's say again 15 meters per second. This was 100 meters. V final you can find as Pythagorean theorem as Vx squared plus Vy squared. Now Vx squared doesn't change, so it's going to be 15. As for Vy squared, you have two options. You can do Vy equals g times change in t. So in this case, it's going to be 9.81 times root of 200 over 9.81. Your other option, you can find Vy as the square root of 2g change in y. Either way, you're going to end up with the same. So that gives me a 44 meters per second. Root of 15 squared plus 44 squared. That gives me 46 meters per second. And again, you need to find, if you're an honor student, to earn some extra credit, you need to figure out what this angle is. You can find it as inverse tangent. This is your Vx, and this is your Vy, and you are trying to figure out this angle. So this is the opposite. So this is Vy. So you are going to use tangent inverse function since you're looking for the angle. And you're going to take the opposite, which is Vy over Vx. So in our case, it's going to be inverse 10 of 44 over 15. And that should give you 71 degrees.